We're going to start with some quadratic words, and I'm going to write out, main thing here is like if I see the question, what can I push on my calculator? So for the quadratic applications, my equation is going to be y is equal to negative 16t squared plus vt plus h. So your y here, this is your ending height. Your t is your time. V is your velocity. And h is your starting height. Alright, so some key words. So if I have like a question, how long is it in the air? So long, you're looking for time. How long until it hits the ground? Again, you're looking for time, the t. Well, when it hits the ground, what would the height be when it hits the ground?
0.
0. So this would be a height of 0. So your height of 0 is going to be here. It's going to end up being your ending height. Y is equal to 0. So what are they asking? They're asking for your x-intercepts, which are your, also called your zeros. And if we were doing this by hand, the way is that we would do it by hand, we could factor it. We could complete the square. We could use quadratic formula or graphing. We're going to focus on using the calculator, which is going to be the graphing. As next unit will be more of the other three. Alright, so the calculator buttons, what we would hit, we would do a second trace. So this would be once you are on the graph. Second trace, and then number 2, which is 0. So you have to be on the graph. Alright, next, how long until it reaches a maximum height? So again, how long? We're looking for the time. Maximum height. Where would I find the maximum height? The vertex. Yes, the vertex. So what are they asking for? They're asking for the x value of the vertex, or which is also the axis of symmetry. So to find that x value of the vertex, it would be x is equal to the negative b over 2a. And in your calculator, once you are on the graph, it would be a second trace, and then you would go down to the number 4, which is max for your maximums. All right, the next one, what is its maximum height? So again, this maximum is your vertex, but this time we're looking for the height, which is your y value of that vertex. And you would find it the exact same way as you did above, the second trace max. And last one here, how high? So high, you're after x seconds. So what you would do is you would put in this in for x. So whatever number you had. So x would be, let's say it was like 2 seconds, then you would plug in x of 2, and you would solve for y. So how high is going to be your y? So you're just finding the y value of the given x coordinate. Just plugging x into the equation and you're solving for y. And then for the calculator step, again, you have to be on the graph for this. And then once you're on the graph, you're going to hit second trace, and then you're going to select the one that says value. And it's going to say x equals at the bottom of your screen, and you're just going to type in whatever x value you need, and it'll enter, and then you'll get your y value. All right, quadratic applications. So the first one, number one, the path of a baseball after it has been hit is modeled by the function h is equal to negative 0.0028 d squared plus d plus 3, where h is the height in feet of the baseball and d is the distance in feet when the baseball is from the home plate. So a little bit different than the equation, then y is equal to the negative 16 t squared plus bt plus h, but similar concept of what we're trying to find. So A, what is the maximum height reached by the baseball? So your maximum, this is your vertex. Your maximum height reached by the baseball is going to be your h. So I want that y value of the vertex. So what we first have to do in our calculator, we have to go into y equals, and we're going to have to type this equation in. So I hit graph, and it looks linear, not quadratic. So let's zoom. I go to zoom 0. Let's see what happens. Did I? Did y'all do the same thing as mine?
Yeah.
Okay.
Oh, wait.
Let's see. Okay, let me look at the windows. Okay, got that part on the screen. So I'm just messing with my window. Okay. Now I'm gonna. Okay, this is what I have for my window. I have -10 for the X-Men, and the max I put as 500. And then Y-Men, I did -50 and Y-max 200. You can have something slightly different.
I'd like to change this.
You got the window button right here up top.
How do you exit it?
Oh, graph.
Alright, shh. So now I'm gonna just the graph button here. So we need the vertex. So going back to our quadratic words, we're gonna hit second, trace, and my vertex is a maximum, so we're gonna scroll down and hit 4. Now it says left bound, so with you see like the little spider thing, you have to use your arrows, and I need to be somewhere to the left of the vertex. It doesn't matter where. Once you get to the left, you're going to hit enter, and then it's going to say right bound. So scroll to the right, enter, doesn't matter where, as long as it's to the right, hit enter again. And we can see down at the bottom our vertex. So, yeah, if it says guess, just hit enter. You don't have to guess. So the Y value here is 92. I'm going to round to 3 decimal places, so the thousandths. So 2857, so 286. And what are we measuring here? Units. Feet. Now if I look at question B, it says how far is the baseball from home plate when it reaches its maximum height? So we are still looking at the vertex. Yes?
Is there a mode you have to be in? 'Cause mine got it like the graph completely wrong. It was like going.
You have to change the window.
Yeah, I did.
Okay, just give me a second. So how far is the baseball from home plate when it reaches the maximum height? So this is going to be the X value of that vertex. So the X value of the vertex here is 178.571, and then we're still measuring in feet.
Smaller, just
All right, next question. How far does the ball travel? So how far does the ball travel? So the ball starting here, it goes up and then it comes back down. So we want to know how far. So what we are looking for here is your x-intercept, which is your 0. So we're trying to figure out here that distance, how far did it travel. So to do that, you're going to hit the second trace again. And this time you're going to hit 2, which is 0. So see how it says left bound and right bound? So that's why I adjusted my window so I could see a little bit below. So left bound, left side, it doesn't matter where you put it. And the right bound of that 0 guess, just hit enter, and it gives you the 0. I know it doesn't say 0 here, but negative, what does it say? -1e to the -11 in scientific notation. So -1 times 10 to the -11 exponent, lot of 0, so it's practically, that means it's practically 0. So my value here is 360.118 feet. All right, D, the green monster located in left field at Fenway Park is a popular target for right-handed hitters. The wall is 315 feet from the home plate and stands about 37 feet tall. Does the ball clear the green monster? If so, by how much? So, what we're looking here, the wall is 315 feet from home plate. So that means my D, which is your X, is 315. Well, I want to know what the height is at 315 in this equation. So using your graph, you're going to hit second trace. And this is where we're going to do number 1, value, and then see how here X at the bottom. What do we want to put in? The 315, and then you hit enter, and we see that Y value, which is also our H, is 40.17. So the wall is 315 feet from home plate and stands about 37 feet tall. Well, using my equation, 315 feet, the ball is at a height of approximately 40 feet. So will the ball clear the green monster?
Yeah.
Yes. Because 37 and this is 40.
Wait, I don't know what it was asking.
Because, well, you're looking for, does the ball clear the green monster? So using my equation, if the wall is 37 feet tall, we want to see, and it's 350 feet from home plate, we want to see, okay, is it going to, is the ball going to go over? So we have our equation. So 315 feet, let's say, is right here. So 315 feet, we've got this wall right here, which is 37 feet tall. We're trying to see, is the ball going to go over it, or is it going to go under? If it goes over, then it's going to clear it. So I need to figure out, using my equation, if this is 315 feet from home plate, what would my Y value be in my equation of 315?
So home plate would be
In a roundabout way, yes. The reason why I hesitated there is because the +3 in your equation, so your ball is actually starting, but yes, 3 feet above what we would consider the origin. Alright, so then it says by how much? Well, 40.17 minus 37 is 3.17 feet. Any questions? All right, let's do the next one. Suppose you are tossing an apple up to a friend on a 3rd-story balcony. The apple is thrown with an initial velocity of 38 feet per second straight up. The apple left your hand at a height of 5 feet from the ground. Your friend is at a height of 20 feet directly above. So, my equation, y is equal to, so this is where we're going to do the negative 16 t squared plus bt plus h. So, negative 16 t squared, initial velocity of 38 feet per second straight up. So, plus 38t, and we are 5 feet from the ground. So my starting height is 5. All right, A, how long does the apple take to reach your friend? So how long, we're looking at time. Well, I need to know what would my height be. Well, your friend is at a height of 20 feet directly above. We throw the apple, though, 5 feet from the ground. So the way that I interpret that, 20 feet above where we threw the apple, so 20 plus 5 would be 25. All right, now we're going to do this one slightly different. So we're going to go into your calculator, and y equals, we're going to do the negative 16t squared plus 38t plus 5. Now, in our options, so like when we calculate value, we have to input an x. There is not an option on second trace to like put in a y value to find your x. So what we're going to do, we're going to put this first equation and y equals, and then we're going to put this equation and the second and y2. So we know y is equal to 25. I'm going to graph, our graph is probably way off based, yeah. So, yeah, we can't even see it. So zoom, I'm going to do zoom 0, let's see what happens. Nope. Nope. I'm done. All right, what I did first, I still have to fix it, but I did zoom 6, I put it back in the standard of -10 to +10 for the X and Y. And then I'm going to adjust my window from there. I know that I need higher up. Well, we know that for sure because we're trying to at least look at 25. So I'm going to say Y max of 30. Now you can see it. You can adjust however you want.
On the test, we didn't have to know like how to navigate the 36.
Yeah, you have to know how to navigate and adjust your window. All right, so the ball is being thrown up in the air. The graph crosses the Y value of 25 2 times. All right, so if you hit second, trace, and then we're going to go down to 5 where it says intersect. So where it says first curve, just pick any, hit enter, and then second curve, doesn't matter where, just make sure it's on the line, hit enter. Guess, you don't have to guess, hit enter. And then if you see down here at the bottom, it does have a Y value of 25, and I have an X value here, which is X is our T. So 0.787 seconds.
Wait, is it okay if you got like something weird? Like I got
0.7. Just real quick, check your equation to make sure that everything is.
What does it mean, first and second curve? What does it mean, first and second?
So, if you look here at your graph, so it goes up, and then we have another, let's say she doesn't catch it, then she has another chance to catch it. So we're going to do a second trace again, intersect, and then now you're just going to scroll like kind of to the other side of the vertex, enter. I did something wrong. Chose the wrong one, that's why. So first curve, second curve, enter, and then we get another value of 1.5876, so 1.588 seconds. All right, so question B. Actually, we kind of literally just talked about this when I did the first one, A. So if your friend doesn't catch the apple on the first try, will they have another chance?
No.
Yes.
Yes. So when will that be? At 1.588 seconds. So it takes the 0.7 seconds to reach her, and then, like I said, that other T when it comes back down, so that would be your second time if she doesn't catch it the first time.
So if we have a question like that on the test, do we have to put both on the question? Or?
If you have one like this and you do end up putting both, it's okay. No, I mean, if it was worded a little different, where we knew for sure that we wanted that very first one, then that would be different.
Okay.
But no, I would be okay with it.
Oh, would it be okay to just put one if it's worded just like that?
Yeah,
Okay.
that would be okay too. All right, next, 3. Definitely pay attention to this one, guys. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway. If the farmer does not fence the side along the highway, what is the largest area that can be enclosed? So, area is length times width. Let's draw a picture here. So he wants to fit 2,000 meters of fencing, wants to enclose a rectangular plot that borders a straight highway. So if here's my highway, so let's say here's my highway right here. We're not going to fence the side along the highway, so this side we're not going to fence. We have 2,000 meters of fencing. So let's say that this is X and this is X. So X amount of fence. So I have X amount of fence and X amount of fence. The remaining amount has to go here. So we started with 2,000. Okay, I put X amount here and X amount here. So it was a number, like if this was 100 and this was 100, we would do, 2,000 minus 100 minus 100, so 2,000 minus 200 to figure out how much would be here. But I do not know what these values are. But I do know that I need to subtract both of them, so X plus X is 2X. Now, formula, area is equal to length times width. So area is equal to, we can say X times 2,000 minus 2X. Question, what is the largest area that can be enclosed? So what we are looking here, we're looking for the maximum of that vertex. So let's think about what's going to happen when I graph this. All right, so area, I know my y value, this side is area. Now, my X, we'll say, is like your length. Well, if we multiply this out, so you don't have to, this would be 2,000x minus 2x squared. You can see that it's quadratic. So we would start here at 0, 0, because if x is 0, I don't have any area, so it's going to come up, and then it's going to come back down. So right here would be your vertex, your maximum, and you can see, given the picture, see how that would be your greatest area? All right, so in your calculator, we're going to put this equation. I don't care which way you put it. Clear out that y2. You don't need it anymore. And I'm going to hit zoom 0. Let's see what happens, how it fits it on the graph. Should be good enough. I can see the vertex. So then second trace, and then you'll do the maximum, and then where it says left bound, so scroll left, make sure that you can see that it's to your left of the vertex, enter, and then again right, make sure you can see that that spider thing is to the right of the vertex, yes, enter, enter, and you can see here,
Can you rewind?
yeah,
What's
Wait,
in
why
window?
didn't you?
what did I,
What do you have in window?
How do you get the graph?
hold on, I messed up, hold on, I forgot my X here. Yeah, I have to change this all. Okay, my zoom 0.
Whoa, that's a big one.
Wrong.
Hey, shh.
Start impatient, that's good.
So yes, the other way is once you hit zoom 0, if you did go back to the zoom and see how it says zoom out, you could just, when you zoom out, does it give the whole thing?
If you zoom out like multiple times.
You have to
yeah.
keep zooming out multiple times.
But then it does.
Yeah, and that works too. Alright, so
I put 75,000.
So going back to the graph, now we want that maximum vertex, so second trace, the max. So go to the left of the cursor, or to the vertex, I mean right. And if you look here, we want that Y value of the vertex. So my largest area is how many zeros? 1, 2, 3, 4, 5. Alright, is 500,000, and we are measuring here in meters. Alright, last one. Artillerymen on a hillside are trying to hit a target behind a mountain on the other side of the river. Their cannon is at 250, where X is in kilometers and Y is in meters. The target is at -250. In order to avoid hitting the mountain on the other side of the river, the projectile from the cannon must go through the point -1, 410. Write the particular equation of the parabolic path of the projectile. So, I have here several different points. I have a point here, here, and here. So I'm going to make a table of those points. So we have 3, 250, -2,
You're doing our calculator.
50, and -1, 410. So what we have to do here, we're going to be doing quadratic regression. So we've done this before with linear.
I got this. Stat.
Alright, so you're going to go to stat, edit. If you have stuff in, clear your list. And then type in your points. So remember stat, edit. And we're going to do the stat calc. Close that, scroll over to calc, and this time we're going to do quadratic, which is 5. Enter, calculate. And we have the equation y is equal to negative 80 x squared plus 120x plus 610. He says approximately where will the projectile be when y is equal to 130. So this is where again we want to do the intersection. So in y1 we are going to type in the negative 80x squared plus 120x plus 610. And then in y2 we're going to put in 130. So my y equals y2 is 130. Nope. So for this one, you can kind of look at your graph to see which we need for the min and max. So approximately where will the projectile be when y is equal to 130? So you're going to find your intersections. So first curve, second curve, enter, we get x is equal to negative 1.812. And then we're going to do it again, second trace, intersect. First curve, I'm going to go closer to that intersection. Second curve.
Wouldn't x 3.312 not really be realistic because it's going to be past the cannon from where it's being shot from?
Correct. Yes, I was just about to address that. So yes, you are correct. This value of 3.312 would not be valid because the cannon is at an x value of 3. X value of 3.312 would be past the cannon. So this would be your answer. And I guess we're measuring in kilometers. So then the last one, see, a reconnaissance plane is flying at 660 meters above the river. Is it in danger of being hit by projectiles fired along this parabolic path? Well, to know, don't we need to figure out the maximum height that it's going to go? So we have to figure out the maximum. So second trace, maximum, You on the left side of your vertex, right side. So if you look here at your vertex, we need that y value. So your max height is 655. The plane is lying 660 meters above the river. So will the plane get hit?
No.
No. Your max height is less than that 660 meters.